Hi everyone, welcome to Secure Deployments at Scale on AWS. I'm Lorna Ekmekçoğlu. I'm a Senior Solutions Architect at AWS, and I'm here with Jack Yu.
Hi everyone, my name is Jack Yu. I'm a Principal Solutions Architect in AWS. I spent many years in the industry helping my customers to address their technical challenges and design the right optimal architecture to achieve the business outcome. Over the years, Lerna and I work with many large enterprise customers, and we work with many different teams in these different organizations, like the central IT team, the platform team, the development teams, the security teams, you name it. And there are some common themes and challenges that these different organizations are facing when it comes to software and infrastructure deployment. The first common challenges that we have seen is the deployment agility. Some organization would have two deployments in a year, and each deployment would require big coordination with many different teams. And some worst case scenario that we have seen is that the deployment happened over the weekend and the deployment would have failed and the system can't be actually recovered and rolled back to the original state. And the second challenge is that the security team got involved so late in the SDLC cycle. And very often they do some type of security scanning in the late stage and some vulnerability will be found and the deployment will be called off. So how do we address that and involve the security upfront in the development lifecycle? The third common challenges that we've seen is the deployment scalability. When organizations grow, many customers will suffer from not being able to scale their environment as they go. So what is the optimum architecture in order to scale the environment so that the app team can deploy fast while staying secure? So learner, how do we balance deployment agility and security?
In races like this, drivers compete to get to the finish line as fast as they can. Up until 50 years ago, this resulted in high speed crashes. In response to that, organizers started installing safety measures like the guardrails that you're seeing all the way in the back of this picture. So guardrails, they prevent cars from running off track and they minimize severity of crashes upon high-speed impact. So similarly, when we build our applications, we want to develop and deploy new features for our stakeholders as fast as we can. What are those guardrails to minimize severity of breaking changes for our deployments? One set of guardrails in deployments are tests. And the more tests we have, the more confidence we'll have in the health of our deployments. And the more confidence we have in the health of our deployments, the more frequently we are going to deploy. But how do we deploy repeatably at scale? So for repeatable deployments at scale, we use pipelines. And here's a pipeline at a very high level. So each time a developer commits to the source code repository, the pipeline is getting triggered and it repeatedly performs the same set of steps. So typically we build the app. So there's a build step for that compiles the code. There's a test step in the pipeline that will run automated tests. And there's a deploy step that is going to deploy resources into the target environment. But how can pipelines help increase confidence in our deployments? So for that, let's take a step back and let's take a look at how we develop our applications. So here we're looking at trunk-based development. And for that, we are breaking our changes into small chunks. And as developers, we're working against short-lived branches and we're committing frequently. As a first step, developers are using their local development environment to make their code changes. And here they can use plugins that are within the IDE that detect bugs or issues such as vulnerable dependencies, along with recommendations on how to fix them. So this is a short feedback loop in their local developer environment. And this short feedback loop improves developer experience or developer productivity because they quickly get to know whether their changes broke something and requires fixing or if it's a healthy change. Now, after this, the developer is going to commit the changes to the branch. And for each commit, pipeline gets triggered. So it's going to build the app and it's going to run automated test suite within the pipeline. This is yet another short feedback loop for the developer to know if they made any breaking changes into the code base. So the build and test stages here are acting as guardrails and they minimize the risk of introducing breaking changes into our code base. But so far, we haven't deployed to any environments. So how do we increase confidence in our deployments? When developer is ready with their changes, they're going to get them reviewed and merged into trunk. Now here, the pipeline for trunk gets triggered and we have again the build step, the test step that are finishing quickly within minutes, and finally the deploy step that deploys into the target environment. So each merge to trunk triggers a deployment, and the more frequently we deploy successfully to our environments, the more confidence we gain in our deployments. So we talked about the tests that are baked into our pipelines that are acting as guardrails. But what are some of those guardrails to prevent security related issues in our code base? And that's security scans. So this is how we're preventing unintentional security misconfigurations that would weaken our security posture in our code base. So this could be, for example, if you're doing infrastructure as code, S3 buckets that are configured open to the world, but we didn't intend to open them to the world, or security groups that are open to the world that we open to the world unintentionally. So security scans help us fix this type of issues. And if we shift the security scans all the way to the left, then we can fix them early in SDLC. So as a best practice, we can actually include them within local developer environment, whether it could be an plugin within the IDE, for example. And that way, we are immediately catching these misconfigurations and informing the developer to fix them. Another place where we can bake security scanning is the pipeline. So in the pipeline, we can have a lint step and a security scan step. And this way, again, we catch the issues within the pipeline and inform the developer, right? This is another short feedback loop for the developer. And this way we can minimize risk of security issues to make their way to higher, more critical environments. We're also shortening the time it takes for remediating them. So what are some of those security scanning tools that we can use? There's just way too many to list. So what we have here is a sample of linters and security scan tools that are available out there. And they change, depending on the language that you use. You may be using a different tool, as well as some of these tools actually are multi-purpose. So it's not just one language, like CDK, CloudFormation, Terraform, but also, other platforms like Kubernetes scan, applications deployed on EC2, Lambda, container image scan, and so forth. So if a tool is considered to be supporting, multiple languages or multiple platforms, then in this table it's shown under multi-purpose. So far, up until now, we focused on one workload. So Jack, how do we deploy at scale when it comes to deploying multiple workloads?
So let's take a look at this particular AWS architecture. Some company would start out the architecture like this. So they have one AWS account that contains or consists of many workloads. And each workload would have different corresponding SDLC environments. There's dev, QA, and prod in this case. And then the dev tooling VPC is responsible for deploying the infrastructure applications on these VPCs. And then there is a platform teams and development teams responsible for managing and developing on this environment. So there are four major issues with this architecture. So for those of you who know AWS, let's pause the video and try to identify where these four major issues is. We're back. Hopefully you can identify all four issues. Let's go over it one by one. The first one is there's only one AWS account that hold multiple workloads. And that is simply not scalable. And you will hit AWS limit or quota left and right. And the worst case scenario, these production workload could be impacted. Second is that these long-term credentials that are assigned to the platform teams and the development teams. And any loss of these credentials would compromise the whole AWS account. Third is the over permissive permissions that are assigned to these credentials. Now the developers can go into the systems and shut down the Kubernetes clusters. And fourth is that there are over permissive permissions on the pipelines. There could be unintended scripts that run the pipeline that could create admin permissions on these particular environments. Okay, so let's take a look at how we improve the environment. Let's start with AWS account. The first improvement that we made is that we made their own SDLC environment to its own AWS account. And just by doing that, we achieved three major benefits. The first one is that the account limit and quota is divided to its own AWS account. For example, if the developer want to use more resources in a dev environment, and it won't impact production workload in that case. The second benefit is that the blast radius is drastically reduced. Let's say there is an Eve coming in and steal one of the dev environment credential. By doing that, Eve would not be able to go into your production environment and try to tamper the workload. So the blast radius is drastically reduced. And the thirdly is much more scalable. Now you can have one, two workload, and then you can have three, four, fifth, and many more workloads by just having this multi-account strategy and designed. Now you get the account squared away. Let's take a look at the next iterations of this architecture improvement. In this iteration, we will tackle the problem number 2 and problem number 3. So problem number 2 is that the platform team and development team would have long-term credential access, you will remember. In this scenario, we are using a concept called IAM role that can issue a short-term credential to the platform team and development team. From the blast radius standpoint, it's drastically reduced. So let's say Eve would get hold of this particular short-term credential. The damage that Eve can do is much less than what it used to. So Eve would only have typically 1 hour windows to assess the environment, which is the damage can be done much less than what it used to. The second improvement is that we will scope down the permission on this particular role. You see, we have the platform roles that assign to the platform, and the permission can probably only be able to create and destroy the Kubernetes cluster or modify some settings in it, and or some database permissions, so that the platform teams can control from the infrastructure aspect what that environment could look like. And from a developer standpoint, they could only access the code repo and probably have read access to the production and QA environment, right? So now we have tackled problem number 2 and number 3. So let's look at how we tackle problem number 4. Final improvement that we made here is to scope down the various deployment roles. So the pipeline would not be able to access the entire ad stage using admin role anymore, if you remember. So the deployment role would scope down such that it only can deploy this particular ECR Docker image into the target Kubernetes environment. And when the pipeline executes, it would use the ECR read-only role to access a particular ECR repository, right? So that it can deploy the Docker image to the intended environment. And this particular, Docker build pipeline would only be able to publish the Docker image to that particular ECR repository. So we'll close down many, many holes in these iterations. Now Eve is unhappy now, like she or he is not going to be able to access or tamper this environment anymore. So learner, let's zoom in the pipeline and see what's the optimal way to architect the pipelines.
So let's dive deeper onto how to construct the pipelines to build at scale. So for that, let's take a look at how we build our houses. Well, we build them layer by layer. So first we lay down the core foundation, then we work on the interior room infrastructure after we lay down the core foundation. So we will lay down the wiring for the electrical, pipes for the plumbing for the interior rooms. And finally, after we're done with that, do we build the inside of the rooms, each according to its own functionality. Like a living room is built differently than a kitchen or a bathroom. So similarly, when we build our workloads, we are building them layer by layer. We start from the bottommost layer with the core infrastructure resources. So here, these can be networking resources typically, like a VPC, subnets, route tables, security groups. And only after we're done with this layer, then we move on to the application infrastructure resources layer. This is, for example, those resources into which our applications will be deployed, like Lambda functions, EC2 instances, containers. It could be databases and storage resources that the application is going to use, an IAM role that the application is going to assume. Only after we're done with these resources do we then build the app layer. That's the topmost layer. So we can build a jar file for Java apps or a zipped up tar file for Python apps and so forth. But how often do we update each of these layers? So if you think about a house, how often do we update the exterior of the house or the foundation of the house, right? So exterior of the house, foundation of the house, they have a different life cycle than the interior of the house. We renovate our kitchens and our bathrooms much more frequently than updating the exterior walls for our houses. So they each have a different life cycle, and therefore they each have a different update or release cadence. So release cadences, they differ between these layers. So similarly, we deploy our application code much more frequently than application infra, and core infra resources, they are deployed less frequently than app infra, for example. So here I'm showing a sample, release cadence for each of the layers, and you can see the difference. Now, as the release cadence differs in between the layers, we bundle those resources that have a similar life cycle with each other, such that we can minimize risk of unintended changes to critical resources that are updated less frequently, such as VPC, that's in the core infra layer, while we're updating application resources, for example, if they were deployed together. So think about redeploying a VPC every time you do an app deployment. Here you're running the risk of breaking critical core infrastructure. So a misconfigured VPC, that's like a crack in the foundation of our house. So the blast radius for that is all of the VPC. If you misconfigure a VPC, everything inside the VPC could be affected. Similarly, if you have a crack in the foundation of the house, everything inside the house could be affected. So separating deployment for each layer and layering according to the resource lifecycle helps us minimize the blast radius for our deployments. Now, security profile of building the foundation is also pretty sensitive. It requires higher privileges to create and update to a VPC. So now, not everyone, if you think about it, can go around laying out foundation for a house. So given the sensitivity of the privileges that are required, we separate the permissions for these pipelines so we can configure least privilege required for each layer. So for this, we can assign a different IAM role to each layer, and we can scope down those roles' permissions to minimize blast radius using tools like IAM Access Analyzer. Now let's take a look again at our security scans, but layer by layer this time. So we had mentioned the tools that were available to you, and you can map those tools now to various layers. So for example, infra as code tools versus application security scan tools. And here also we are seeing the types of security misconfigurations we can prevent layer by layer by performing security scans. Finally, in the key takeaways, we have shift security scan left in SDLC to minimize risk of vulnerabilities in application code and misconfiguration in infrastructure as code early on in the SDLC. Use multi-account strategy to contain resources that belong together based on their security and access profile and to minimize blast radius. Group resources with the same lifecycle in the same pipeline to minimize blast radius of unintentional breaking changes in a deployment to more critical but less frequently deployed resources. And scope down pipeline deployment roles to least privilege to minimize blast radius of each type of pipeline. So we thank you. And here is another blog post that we have with Jack. If you're interested in this topic, you may be interested in that. And the blog post also has open source code that's about multi-region deployments at scale. So we thank you for joining us.